Hi, namaste. Good morning and good evening to everyone. Today we are going to discuss about prerequisites for data science and data science. So the prerequisites over here is the statistics. So I am Poornachand. I have more than 12 and a half years in data science. I am the co-founder of dataveda.com. Let's get into prerequisites for data science. So if you have looked into or if you have followed my previous session into what is data science 101, this is what data science 102, you will be able to see what we are going to cover in this particular session. So as we discussed earlier, we are going to see what is the mathematics, what are the mathematics and understanding behind the data science. The initial bread and butter is statistics. So the purpose of this particular session is to understand mathematics behind data science concepts, especially the statistics. So before going into the statistics, we have to understand what types of data which is available in the uh, uh, available in the out in everywhere. Okay, so we need to understand what type of data points we have and how those data points are going to help us to get into a specific conclusion. So here we are going to see what type of data points which are available. It should start from numerical data points, which means numbers, and categorical data points, then text data points. So in numerical data points, if we see, we have continuous as well as discrete data points, whereas in categorical data points, you have nominal and ordinal data points. Text data points also we have, where we have structured data and unstructured data, unstructured text, which are available in different places. Here, when I say unstructured data, it can be a document, or it can be a comment in a social media post, or it can be any form of text which is kept in a more unstructured manner. Whereas structured manner, you have different CSVs, different files, XML files, you have CSVs, you have Excels, and you have JSON files, so on and so forth. Time series data, we talk about when we talk about time series data. If a data point is being associated to a specific point in time, then we call that as those series of data points as is called as time series data point. We have geospatial data points where the latitude and longitude of a specific place is being captured at geospatial data point level. Image data points, we have RGB color coding, and we have color point level data points which are available to represent an image. And audio data points are as simple as type of audio format and what kind of amplitude, what kind of values which are being associated to that particular audio. Let's look into this set of data points, data types, and then understand how they look. So we have data types, as I explained. We have numerical data points, categorical data points, text, and time series data points. So discrete, under numerical data points, we have discrete data points. You have all these values, discrete values. So for example, people can ask to give an example of discrete data points. I can say how many number of people reside in your home. You will say 3 or 4 or 5, a specific number, but you will not say 3.5 or 2.5. Whereas in continuous data points, you can say what is your weight. Okay, you can say as approximate as 73.67 kilograms, right? So it's a continuous value. And when it comes to categorical data, we have nominal and ordinal data. Nominal data is as simple as number of cities or the city names in a specific state. Or then when it comes to ordinal data, the type of satisfaction level of a specific food. You can just take an example of that. So I can say I'm very satisfied, or I can say very dissatisfied, or neutral, or satisfied. So the difference between these two are as simple as that. It's a feeling, I can say, when it comes to ordinal data, or it's an ordered value. Okay, in a scale which is defined, is called as ordinal data. When it comes to text data, as I explained earlier, structured data in different text files like CSV files, Excel file, JSON file, and XML file. Whereas unstructured data is as simple as a document data, or articles, data in articles, or data from comments or social media data, so on and so forth. Time series data, here I have given a time series data of 20 data points, of 20 different dates of an year where the value is of minimum temperature calculated or observed in that particular date. So that is called time series data. So with this data, what will we do? So now we understood what is the data. Now we are going to see what kind of descriptive statistics, what is the summary of this particular data we are going to understand. So, as simple as mean, median, mode, we call them as measures of central tendency. You need to learn and you need to understand the depth of it so that you should be able to visualize where to use mean and where to use median and mode based on the requirement. You have range, and range is nothing but the difference between min and max, and variance, how our mean and how our standard deviation and how our percentile being calculated, we are going to see in the next summary sheet. So this is the data, let's assume, and this we are going to see the descriptive statistics. So you can see the discrete data. So this is the discrete data, discrete column and continuous column, the summary of discrete and continuous over here. You have mean. The mean is nothing but total sum of the entire data points divided by total number of data points. You are going to get mean. And you have median, you have mode, all those values, and you have standard deviation and sample variance, and you have range as I explained, the min and max. You are seeing min and max. The difference between min and max is the range, and total sum and total number of values over here. Okay, so this is what as simple as simplest possible descriptive summary of a specific data. This is how you see, you visualize, you understand the data in at first whenever you see the data. Next, you will see how this data is being visualized. So we have several visualization techniques. We have histograms where the data is represented as part of distribution of numerical data, whereas box plots, we have graphical summary of distribution of numerical data through quartiles. Okay, and we have scatter plots where we need to visualize the representation of data between variables, two numerical variables we are going to see, and how bar charts and pie charts being represented in the as part of the categorical data or even any other forms of data. So we are going to see a small piece of Python code to understand or to run or extract this kind of data. So how to plot these data in Python? So I've used VS Studio for my Python, and these are the libraries which I've imported in order to run the code. I'm going to show my Python workbook, and this is as simple as a small code. Anyone can write very simple code. All you need to do is first you have to import MATLAB, so matplot library.pyplot as PLT. So this is my alias I have taken to run a small line plot. So I have generated my sample data. Very simple. X, I have created a small set of values 1, 2, 3, 4, 5. Y as 2, 4, 6, 8, 10. And I wrote PLT. I have imported plot and I wrote plot PLT dot plot X comma Y will generate my line plot. So this is my line plot. So you see the x-axis and you see the y-axis and there is a line plot. Then again, all you need to do is define the plot and define the x-axis and y-axis and then give the title to make it more readable and then click on show. Then I'm going to look at scatter plot. Again, same thing, plt.scatter, give x and y as a parameter, and you will see a scatter plot with this data which we have generated just now. So this is the scatter plot. Then for histogram, I need a set of data and I need some bins to see. Bins are nothing but how much frequency, how many data points are there in a specific set. The bin means a range from 0 to 5, 5 to 10, 10 to 15, so on and so forth. We are going to see a histogram how we have created using Python. So I have created a data his underscore hist. This is my data. I used np numpy as my library. From I have imported this library in the second line of this particular code. This is to generate. This is to run my numpy value in order to create a random data for this particular plot. Okay, so now close this. Now it will run histogram. You can see these are the bins between -3 to -2, -2 to -1, -1 to 0, 0 to 1, 2, 3, 4, so on. These are my bins. Under these bins, I have how many values or how many values are available in between this range to this range is my frequency of these values. And the value, how many number of zeros, how many number of minus ones, how many number of minus twos, and I have the frequency of them, and I have run this histogram, and I can see the histogram plot over here. The next one is bar chart. For bar chart, all I need to do is create X and Y. See where to use the bar chart. Earlier we were talking about line graph when we have continuous data or discrete data. Here we are looking into categorical data where we can see category A has the 20 points, category B has 35 points, category C has 30, and category D has 25 points. So here we have created a sample data with two different columns, one category, another one is values for that particular category, and create a bar chart. Earlier we were saying plt dot scatter, plt dot plot, plt dot plot, plt dot scatter, and plt dot histogram. Now we are clicking on writing on plt dot bar. We have provided categories and values, and this is the outcome we have received as part of the visualized value over here. Then next we are going to create a box plot to understand the quartile ranges between these particular values. So this is the data, and this is the box plot which we are seeing. For again, for this also, you need in order to generate the random number using numpy, we have created data underscore box as a data set, and then here instead of PLT, we have to use Seaborn as our SNS as our box for our box plot. Okay, for statistical values, we are using SNS.boxplot. We have received box plot over here. And then the last one, we have to create a heat map. What is heat map? Uh, the intensity at which the density of the values at which they have been cluttered at these points, and there it's being represented as color coded from 0 to 1. This is what I kept as color code as 0 to 1, and CMAP is nothing. The data we have passed is data underscore heat map. Again, where random values between 10 and 10, and then data we have created a heat map, and CMAP is the type of type of map we have created. The color code map which we have created is this, and this is the heat map which we have created. So these are some ways of generating different types of data visualizations. See, this is as simple as our plotting data visualization in Python. What are our next steps? Now we understood a basics of statistics. In next session, we would like to get a little bit of linear algebra also, where we will be understanding the concept of a line, and then why it is being used just to represent or just to understand the outcome variable versus input variable in any type of machine learning algorithm. So in order to understand machine learning fundamentals, you need to know all these mathematical concepts at least to run and code in any programming language. Followed by, we will look into some BA tools by data pre-processing, visualization techniques, and then we will again try to understand big data tools and technologies. And in the end, we are going to do some 25 to 30 projects, real world problems in Python using machine learning algorithms. Okay, where to follow these videos? Again, please follow our Data Weather LinkedIn page. or and look for content over there as well as in my website. Please subscribe to this particular video link. Hopefully, I will try to convey even more, or I can solve more of your questions if at all you are posting in the comment section. Thank you so much. Have a great day.